Greetings, I'm Ben, and in this video I'm going to show you a couple of ways to deal with a couple of different types of missing data. So to start with, let's look at this data set. Well, to start, I guess I should say, I am going to be using a command from the package janitor. So I would recommend installing and loading the package janitor if you want to use this command, and it's a table command, and I'll show you why I like it. And then we'll also be leveraging the tidyverse here, and so I recommend installing and loading the tidyverse. Specifically, we'll be using tidyr and dplyr. And then I like to increase the max print, so options parentheses max.print equals, and I just put I think 100,000 or 1,000,000 or something, and then close the parentheses. And I like to run that command just because the summary of the data set can sometimes produce a lot of rows, and if you reach your limit, then you won't see the full summary of the data set. So the data set that we're working with here is data set from DebateWatch experiments that we conducted here. So the X variable is just a count of participants, so it just gives every participant a number. The debate variable indicates whether it was the first debate or the second debate that people were watching. This is between Donald Trump and Joe Biden in the 2020 election. And then we have age, race, gender, religion, the pre-debate vote preference, partisanship, which is party 7, some feeling thermometers for Joe Biden, Donald Trump, Kamala Harris, Mike Pence, academics, immigrants, the police, and the Black Lives Matter movement, and those are all pre-debate, so the letters PRE are attached. Some scales that we were interested in, and then we have Donald Trump's image and Joe Biden's image pre-debate. Then we have the 4 experimental conditions for our experiment, and so they're called control, mixed, DEMCON, and REPCON. And then we have some post-debate variables. So the post-debate vote preference is vote 7 PO. Then we, DB win is who did you think won the debate. We have feeling thermometers for the post-debate. We have a scale that we were interested in post-debate, and then Donald Trump and Joe Biden's image post-debate. And then we have this count NA variable, which is a variable that I'll show you how to create here, but that's one that we'll be making in this example. So you can also, so if you run nrow parentheses DEB close parentheses, or the DEB here is the name of our data set. So if you run nrow and then in the parentheses put the name of your data set, it'll tell you how many observations you have or how many units of analysis you have. And so I run that here, and it shows us that we have 340 participants in our DebateWatch experiment. And then if I use the summary command, so summary parentheses and then the data set's name, so this would be summary left paren DEB right paren. That will give us a summary of all of the variables in the data set. And so this is where when I increased the max print, it's because you can easily run out of rows to summarize all of the variables, but you also might not like summarizing all of the variables at once. It can be overwhelming, it's a lot of variables, and so I actually want to summarize just a few variables. So what I'm going to do is run summary left paren DEB, so that's the name of the data set or the data frame, and then bracket C left paren, and then I'm going to list all of the variables that I want summarized. So in a single quotation mark or an upside down comma, I put the name of the variable I want summarized, and so here I'm putting age in that single quotation mark, and then outside of the quotation mark I'm putting a comma, and then the next variable, so single left quotation, FT underscore capital JB PRE, and then close the parentheses, and that's feeling thermometer Joe Biden pre. And then I put another comma, and in that single parentheses I'm putting feeling thermometer Donald Trump pre, and another comma, and then I'm putting in a single parenthesis the word control. And notice that it is cap sensitive, so the fact that I have in my data frame the C in control is capitalized, it needs to be here. And then I close out the parentheses on that list. And so essentially what I've done is created a list of variables that I want summarized: age, Joe Biden feeling thermometer, Donald Trump feeling thermometer, and control. And then I close out the bracket, put a comma, and this is optional. I just put digits equals 4, and that tells me how many digits it's going to report here. So if I run that, then it just gives me a summary of age, the 2 feeling thermometer variables, and the control variable. And this is important because this is the 3 different types of missingness that we're going to deal with in this video. So for age, now in R, just as a reminder, NA is the code for missing. So for age, it says minimum 17, first quartile 19, median 20, mean 21.17, third quartile 21, and max 67. So as you can see, this is a college student sample. Most people are between the ages of 19 and 21, but there are a few people who are older than that, maybe non-traditional students, maybe members of the community who just wanted to participate in the debate watch. But we have 27 people that didn't report their age, and that's problematic, and primarily because we're not really concerned about their age. It's a college student sample, but if we do use age in an analysis, those 27 people, if we use it, for example, in a regression model, those 27 people will be deleted out of the analysis, and so we'll lose actually, a fair amount of power and a fair amount of information just because we didn't force people to report their age and 27 people elected not to. And the other thing is we don't really have anything in this data set that would help us estimate what somebody's age is going to be. So for these, we have 2 people that didn't give us a feeling thermometer for Joe Biden in the pre-debate, but they may have given us a feeling thermometer for Joe Biden in the post-debate. And they've given us Joe Biden image scores, and they've told us how they feel about Donald Trump, and they've told us their partisanship. And so there are a lot of variables that we can use to estimate what those 2 people would have given us if they'd have given us a score. And then for Donald Trump's pre-debate feeling thermometer, there are 6 people that didn't give us the score there, but we'll be able to estimate what they probably would have given us using all of the information that they did provide and everything we know about all of the other variables in the data set. So for these 2 feeling thermometer scores, we'll actually be able to estimate what the score would have been based on everything else that they provided to us. And that's better for us so that we can retain these variables and these cases in the analysis and have a good sense of what would have been there. So the third type of missingness is what we have for the control condition. Now, notice that this is minimum 16, first quartile 16, mean 16, median 16, third quartile 16, max 16. So the 16 is just ideally that would be a 1, and eventually when we use this for analysis we'll have to change the 16 to a 1. I don't know why exactly it gave everybody that was in the control condition a 16, but for whatever reason every individual who's in the control condition got a 16, and everybody who's not in the control condition doesn't have a value. So that's 255 people that weren't in the control condition. And here we can actually use the table command from Janitor that I referenced. So if we do TABYL, that's the table command from Janitor. So TABYL, and then open our parentheses. The data set is DEB, and then $age. That will give us how many people are each age. So, 1 person is 17, 49 people are 18, 91 people are 19, 62 people are 20, 48 people are 21, 25 people are 22. 1 person is 67, 1 person is 57, 1 person is 51, and then we have those 27 NAs. If we also run that same command, so TABYL left paren DEB $, and then we do control, and then close the paren, it'll show us that 85 people have 16, which just means 85 people were in the control condition, and 255 people have NA. So the first thing we want to do is find out if there's anybody in our data set that actually didn't respond to most of the questions. So if we have a case where most of the values are missing, or somebody who just has too many missing variables, and so we don't have enough information about them to guess what they would have replied. So if we run this data.frame, open parentheses, call names, open parentheses, DEB, or whatever the name of your data frame is, and then close the parentheses, so right paren twice, that will give us a list of all of our variables in the data set, and it'll give us a number associated with them. So it'll tell us which column number each variable is. And that's handy for a variety of reasons. But here I'm just running it to find out how many variables I have in the data set. And so 76 is the last variable of interest here. That's Joe Biden's image post-test, post-debate 7. And the X is just a count variable. The debate is just a which debate does this data come from variable. And so age is really the first item that they respond. And so that's the third variable. And so we can say, all right, I want you, so now what we're going to do is create a count variable that tells us how many missing variables are there. And so the new variable is going to be called count NA. You can name this variable whatever you want, so we'll create another, we could call it missing, but I'm just going to call it count NA. And so again, you use your data frame name, $, count NA, and then equals, or sometimes I use the little caret, but say equals, and then row sums is the command. So ROW, capital S, UMS. And then left paren is dot NA, and then another left paren, and then DEB is the name of our data set, so whatever your data frame name is, and then a bracket, comma, I don't know if the comma is necessary, but I put it in there, C, and again, C is just how you list in R, left paren, and then, I have 1:76, but we could do 3 because there's no missingness. And so instead of 1, we could do 3. So we could do 3:76. It doesn't matter because debate and X are, so the first two, 1 and 2, are variables that I provided the values for, so there's nothing missing there. But starting at age and going all the way down to the 76th variable, which is Joe Biden image post 7. Those are all values provided by the participants. So then I put a right paren, which closes out that C column. And then I put a right bracket, and then another right paren, and another right paren. So the first right paren closes out the C3 column 76. The bracket closes out the, the one I started with, the deb bracket. Then the next right paren closes out the is NA command, and the last right paren closes out the row sums command. So that gives me the count NA variable. And if I then run table left paren deb $ count NA right paren, so the syntax I have here, if I run that, it'll tell me how many missing values there are. And one thing you'll see is that every single person in the data set has at least 3 missing values. That's because there are 4 conditions. Everybody's only in one of the condition, and right now every condition has NA, for whatever, or every participant has an NA for the 3 conditions they weren't in. Then we have 44 people that are missing 4 columns or 4 variables. And so that's probably a lot of those age, and then of course the 3 the three conditions that they weren't in. We have 5 are missing 7, 6 are missing 4, 7 are missing 2. I'm sorry, this isn't how it goes. 44 people are missing 4 variables, 7 people are missing 5, 4 people are missing 6, 2 people are missing 7, 1 person is missing 8, and 1 person is missing 43. So the row where there are 43 missing variables, that's not really somebody we can use. You know, there are 76 variables in the data set, 74 where people provided an answer. So of the 74 answered variables, this person's missing 43. So more than half of the data set. So that's the person we want to get rid of. And to get rid of that person, we're going to go with Deb. We're going to actually create a subset of the Deb data set. So the subset would be, and I'm going to give it a new name. So I'm going to call it Deb1. So I'm creating a new data frame that is basically the entire previous data frame minus the one person that is missing 43 variables in the data frame. So it's going to be Deb1 equals subset is the command that we want, and then left paren Deb, so that's the previous data frame, so whatever data frame you're working with, that's what you put there, and then comma count NA. Now we're using count NA because that's the new variable we created. So remember I said you could call it missing if you want. So if you call it something other than count NA, that's what you have to put here. So if we'd have called it missing, then we would be putting missing right here. But we've called it count NA, so we're going to put that there. And then we're going to say is less than 9. So this means we're keeping everybody whose score on count NA is less than 9. So we're only, in this case, really deleting the person who had 43 as the value in count NA. And then we put a comma, and then select is the columns or the variables that we want to keep in our data frame. So we're going to select X all the way to count NA. So it's select equals X, and X here is capitalized, colon, count NA, close parentheses. So what does that do? It creates a new data set called Deb1, so whatever you name it here is what the new data set will be. And if you keep the name, so if I kept it Deb, then I would write over the old data set with the new data set, which honestly is perfectly sensible because why would I want to keep the data set with that one person in it? But for the sake of maintaining good records, I'll create a new data set called Deb1. And that data set will be a subset of the previous data set called Deb, in which only people who have a count NA score lower than 9 are included, and we're going to include every variable from X to count NA. And X is the first variable in the data set, count NA is the last variable in the data set, so we're including all of the variables. So if I run that, now you'll see if we run the table command, table left paren deb1 $ count NA right paren. You'll see that we don't have the person that has 43 missing variables. And remember, if we say nrow deb, we had 340 participants. If we do nrow deb1, now we have 339 participants. So what have we done? We deleted the person that didn't respond to 43 of the questions in the survey. Now, I am going to pause here, so that just that gives you one strategy to deal with missing data, to delete people who have a lot of missing data. I'm going to pause here and create a new video, and in the next video I'm going to show you how to deal with all of the missing data in age. And what we're going to do is median imputation to just get the median age. And then I think I'll do a third video where I show you how to use mice to impute the other missing values. So I hope you found that useful, and I hope you tune in for the other missing data videos.